Okay, hello everyone. Today these are the two questions which we have to do based on the dimension analysis. In the first question, what we have to do, we have to find out the dimension of this A upon B. They are very important questions. That's why I have selected them for you all. So starting with the first question. In the first question, what we have to do, we have to use the principle of homogeneity. And we know that principle of homogeneity means that the dimension of LHS equals to dimension of RHS. So first of all, I am writing the equation as it is: A minus T square upon Bx. This is the equation given to us. Now change this equation in another form. We can write this equation like this also. Okay, now we can write that the dimension of P is the pressure here, equals to dimension of A upon Bx and minus dimension of T square upon Bx. So if I use the principle of homogeneity, it means that dimension of this equals to this and dimension of this term equals to dimension of this term, or in other words, dimension of this equals to dimension of this. Doing according to the question, in the question we have to find out the dimension of A upon B. So no need of taking this term, isko hata do. I am simply write it dimension of P equals to dimension of P equals to dimension of A upon Bx. X is the length, P is the pressure, and we know that pressure equals to force upon area. The dimension of force is ml, P minus 2, and dimension of area will be L2, and dimension of A upon B we have to calculate, and dimension of X is L. So L get cancelled. So dimension of A upon B equals to M T minus 2. So this is your answer. This is the answer for question number 1. Now doing question number 2. Coming to question number 2. In question number 2, what we have to do, we have to find out the dimension of this V. V is what? V is the velocity, and this eta, it is coefficient of viscosity, and A is the radius and X is the distance. So we need to find out the dimension. So let us take the terms as it is. In terms को ऐसे कैसे ले लेते हैं. First of all, we have to find out the dimension of this eta, but let us take the equation as it is. Equation को as it is पहले ले लो. So we have V equals to pi P A square minus X square upon 2 eta and n. Okay, so we can see that V, dimension of V equals to pi P A square upon 2 eta L minus pi P X square upon 2 n eta L. So we can see that dimension of this V is equal to dimension of this term. So no need of taking this term, simply I am taking this term. So dimension of V equals to dimension of pi P A square upon 2 eta n. Okay, so after this, what we have to do, we don't have the dimension of this eta. Eta की कोई dimension मेरे पास नहीं है. Eta is what? Eta is the coefficient of viscosity, L is the length, P is the pressure, A is the radius. So let us find out the dimension of this eta first. Okay, eta की dimension निकालते हैं according to the formula. This eta equals to 6 pi r. F equals to 6 pi r n v. So this is from here we can find out the value of this. From here we can find out the dimension of this eta. यहाँ से इस फॉर्मूले को यूज करके we can find out the dimension of this eta, where this is the velocity, f is the force, and we don't have any dimension for this constant 6 pi, r is the radius. So from here eta equals to f upon 6 pi rv. Okay, eta equals to f upon 6 pi rv. So we can say the dimension of f will be ml t minus 2. No, they are constant, so they don't have any dimension. So dimension of r will be l only. Dimension of v will be l t minus 1. Solve it. Solve किया इसको. So we get m. This l become 2l, goes up. So l minus 1, and it goes up. So t minus 1. So this is the dimension of this eta. Eta की dimension put करो. P is the pressure. So what is the dimension of pressure? Pressure P equals to force upon area. It is force upon area. So force की dimension क्या है? ml t minus 2, and area is l2. So we get m l minus 1 t minus 2, and what else? L की तो हम लोग we can put directly here. So now say this is first. So from equation 1 पे आ जाओ. Dimension of v equals to कितना? No need of writing this now. P इसको लिखने की जरूरत नहीं है. Straight away write down the dimension of this p. Dimension of p will be m l minus 1 t minus 2. Dimension of a will be l2 only, and dimension of 2 is nothing. Dimension of this eta is m l minus 1 t minus 1, and dimension of this l is l only. So we get v equals to, कुछ cancel हो रहा है तो cancel कर दो. So m, I think mm get cancelled, l minus 1 and l, and I think they get cancelled. और यहाँ पे l minus 1 l2, so we get l l1. So no need of writing this one, and t minus 1 is here. It goes up. So t minus 1. So this is your answer. So v is the velocity, so its dimension is lt minus 1. So in this way we can continue with other questions. Now dimension part is about to finish. Only one use of it is left, and that video I upload on 17. Okay, 17 is Sunday, but I upload that video, so please see that video. So for today it's enough. I give you some questions on the WhatsApp. Please check them. If you have any problem, you can ask me. So thank you very much.